Hydrants. Hydrants are great when you have access to them. I wish I had more of these in the woods, but I don't. Nonetheless, it's important to know how to use them because sometimes it's the only water source you have, and you need some perspective on how they operate so that you can use them when that time comes, because it will come. Right? Like a lot of things we use, hydrants vary from location to location, and we end up with it being out in remote places where your hydrants could be even more variable and less on that standardized function. For example, this hydrant here is sits at about 100, 125 psi, and it's the only hydrant for probably 50 miles any direction. It's out on a national monument. Looking at that picture there, you should minimize any time you spend over top of a hydrant. And I do like the fact he's got a gate valve in place so he can meter and adjust his flow there and shut on and off that hydrant. That way you can just leave the main hydrant open all the time. Dry barrels. These are what we usually have. Um, the main barrel of the hydrant up in here where you get your water out of, it drains out. Note the drain hole down here at the bottom. We'll get a little more in depth on how that works, but when you close that valve, the water drains out these little holes down here, and so that portion that's up above the ground ends up being dry, hence dry barrel. And since it's dry, they use these anywhere where it freezes. Key with them, and remember, these are the ones you run into the most. Key with them is that they need to be opened all the way or closed all the way. A wet barrel, they're always charged. They're wet the whole time. They do not drain. You'll find these places where it doesn't freeze. Um, and to that, I'm not sure I've ever seen one for the most part. But they are out there. You get down southern latitudes where the temperature has a tendency to stay warmer. You could easily run into a wet barrel hydrant. You don't have to be as cognizant in getting that open and closed because the water's not draining out. So I believe you can actually meter off the operating stem a little bit better, or at least a little bit, or probably completely. Dry hydrants. We do have dry hydrants. I know I have dry hydrants. I have several. And in this case, you're seeing how there's a pipe that goes down into a pond and it runs up to the top. And unlike your typical hydrant use, this isn't charged. This is something you draft off of, so you have to use soft or hard suction instead of soft suction. You'll use hard suction on a dry hydrant. Dry hydrants are pretty. They're a lot cheaper to put in if you're getting one type of thing. A dry hydrant can also operate off a tank that's in the ground. So you'd bury a 10,000 gallon tank in the ground and put a couple pipes into it, one to fill it, one to draft out of. And you got yourself a water source out there that didn't require you to run 6-inch main line all the way to wherever this hydrant was. So you'll find this in a lot of rural communities. And probably the important thing is to recognize that it is a dry hydrant and how they operate. They stick into that water source, be it a pond or could even be a river, or very commonly it's a tank. I have several that are just going into tanks in my area. So in this case, this is a dry hydrant. And the problem is that they put a regular old hydrant plug on top of it. And you really shouldn't do that, because if you walk up to this, you're going to think, oh, it's a hydrant, and try and operate it. And really what you need to do is be plugging in hard suction and drafting off of it. Um, this is nowhere local here. This comes from somewhere way out east. But you do run across things like this, like decorative hydrants. I have a neighbor that has a hydrant in his yard, and we do not have a municipal water system. No hydrants. It's decorative. And how would you know? Uh, Really, a dry hydrant should just be a capped pipe that's coming up that you can plug into. But you never know what you're going to run into out there, so be aware of that. So we'll take a look at how to use a hydrant and a little bit about some of the hazards associated with hydrant use, uh, at least from the grander agency perspective side. Um, we'll try and build some more opportunity for a little more specific tutorial how-to on how to operate these things. As we saw in the water hammer video, some pipes in some places are very old. Uh, you know, Prineville had wooden water line until about 3 or 4 years ago. So, and it's not a small city by measure of its current location. Um, there are still some old and or less developed sites in the world, and they may still be plugged into your system. So, old wood water lines, or even old metal water lines, or old anything, potentially susceptible to water hammer. So, something to watch out for. All right, hooking up to a hydrant. When you're operating that stem valve, use a star wrench, use a hydrant wrench. Don't use a pipe wrench, you're going to mess it up, and it's going to be a pain to try to operate it that way. They don't all quite look like the ones in the pictures. Um, the star wrench, some of them are composite, different colors, and will have all kinds of weird attachments on them that do other things, but they have that star piece in the center that will operate a hydrant. Okay, always use the correct thread adapters and reducers. Well, yeah, whenever you're hooking your hoses up to things, you should be using the correct thread adapters and reducers. So what's the correct ones? What are you going to need? For the most part, using hydrants, you're looking at 2.5 on the side ports, and that's usually what's most applicable to our engines. So you're going to need to be able to either plug a 2.5 into that and bring it to your engine, or reduce that down to something that you can use. So my Type 3 is going to be running 2.5. Some of my old Type 6s, if they're still floating around, might have 2.5. But the newer Type 6s are running 2-inch, which is an appropriate size. You're going to have to figure out how to convert from the 2.5 on the hydrant to your 2-inch on your Type 6 engine, assuming that you are running your hose directly into your truck. If you are top filling or something along those lines, it'll be a different matter. So you need to carry appropriate adapters. Probably looking at a 2.5 to 1.5 inch. Those come in handy, especially doing top fills. We have 1.5 inch hose, lots of it. It's pretty readily available to us. If you end up plugging direct into your fire engine on a regular basis, you'll probably want a piece of 2.5 inch hose, soft suction, so that you can pump off that hydrant into your tank, or potentially even off the hydrant into a hose lay. You'll quite possibly need on, say, a Type 6 engine, a reducer or an increaser going from 2.5 to 2-inch. And it just depends on how you configure that and exactly what those components look like on your engine. So the idea is you can, plug into that hydrant and stick it to the back of your engine. All right, when you're hooking up to a hydrant, and we probably briefly scratched on it here, but you open that thing all the way and you leave it all the way open. So you can't meter with the valve in the hydrant. You need to have it all the way open or all the way closed. Hence, we have hydrant attachment valves to help with that. On the left there, you have a 2.5 to inch and a half gated Y ball valve, which is great. You can hook up, set up your hydrant, shut those valves off, and fire up your hydrant so it's charged, and you can meter and or turn off the water flow at that ball valve. On the right is a gate valve, a hydrant gate valve. Same thing, it's just 2.5 to 2.5 with a gate valve in the middle. Uh, the gate valve's great. It's a little it closes more slowly, but it's still meterable, unlike the hydrant, which is not meterable. So you can control the flow going into your truck, or at least into the hose that's going over to your truck. The gate valves are nice. They're a little harder to water hammer. It's hard to close them really quickly and end up with water hammer. Whereas the quarter turn ball valve is pretty easy to water hammer. It's very easy to close that thing in a hurry. So it takes a little extra caution with that. Some hydrant related things here. So the side of a hydrant is generally, not always, but generally 2.5. These guys are a pretty handy little tool for what we tend to do, especially with like a Type 6 engine. You can plug this into the side of your hydrant, open your hydrant all the way up until it stops turning, and then kick it back loose. And plug this guy in. You can stick an 1.5 inch hose off of it, and you can fill your engine off of that. You have one quarter turn valve to open and close it. Important thing, hydrants can be very susceptible to water hammer. Or we think hydrants can be really susceptible to water hammer, and we probably will never move enough volume to really truly water hammer most hydrant systems. But we also run into hydrant systems in the middle of nowhere that may not be nearly as significant as one in a larger city. You know, we had wood water line in the town I live in up until just a few years ago, and I probably still couldn't water hammer it with an 1.5 inch line filling a fire engine. But nonetheless, make a habit of opening and closing, especially closing slowly, and that can be a much better way to meter. Well, it's the only way to meter what's coming out and into your truck, because you can't use the hydrant itself to meter. They need to be open or closed. Now, say you have a Type 3 engine, or you just want to be able to use a 2.5, but you still need to be able to close that thing off and on, and opening and closing the hydrant itself is not your ideal option. You can have a gate valve. This is a hydrant gate, and I think it's about 10 turns, and I'm not counting, but it goes open and closed like that. Much easier, even flowing water, than trying to do the whole hydrant. And also much better. You could theoretically close this fast enough to get some water hammer, but it's much more difficult to do, and you'd have to try. So this will reduce the probability of water hammer, and it will allow you that control to meter the flow in that 2.5 coming into your truck a lot better than, well, I mean, you can't do it off the hydrant. So this one is pre-set up with 2.5 double female, because most of the time my 2.5 hose has one male and one female end on it, just like any other piece of hose. This obviously isn't 2.5. Okay, so that part goes on the side of the hydrant. The hydrant has a male thread that plugs into it. Okay, coming off this side also has a male thread, so I can hook my hose up straight to that, and just like any other piece of hose, like for example this piece of hose, my female end
sticks on my hydrant or on my gate valve. And this comes over to my engine, right? This obviously isn't 2.5, but comes over to my engine, and my engine has male thread coming out of it. So I need that double female to join those two. I actually do it backwards. I take my hose from my engine and I plug it into this, which I leave on my gate valve. Easier for me. I don't care how you do it. Just have a system.
Hydrant use continued. So, say it again. Water hammer is a problem. Open and close all valves slowly to avoid water hammer. When you're opening the main valve in a hydrant, I've never seen anybody be able to actually do it quickly. So it's really the attached valves that you put on it that you can close and open quickly. However, it is, pay attention to things that close fast. You never know what you may run into out there. So then there's this bleed off air, rust, or debris before attaching the hose. That's flushing the hydrant. That's what he's doing in the picture there. He's getting all that rusty nastiness out of there. So you crack that thing open, you can hear the water coming up in it with the cap off, and let it flow some water out until it comes out clear. You'll get rust build up and all kinds of things, rocks and spiders and whatnot. So pop the cap off, you open that hydrant up a little bit, let it fill up, flush that out, and then shut her down, and then attach your gate valve or your hydrant ball valve to it. Then open it up all the way, and you use your add-on valve to meter and or control that flow. Well, this is a little redundant. I think we've said it before, but it's that important. You do not control flow with the main stem valve or the stem nut. You must control your flow with something you've attached to the outside of the hydrant. Always open it completely, always shut it completely. So all the way open, all the way closed. We've said it many times. If you take a look at the diagrams here, that first one shows the hydrant in the closed position, right? The valve's all the way up. In this case, that's how this one's designed. As you're opening that valve, okay, you have water down here, and it starts to flow up into the barrel. That's your washing out or rinsing out your gunk that's left over in there. Okay, but at the same time, you'll see that there's these little arrows coming down here. All right, that's where your water's starting to leak out because the valve needs to be open or closed. It can't be in between. You see when the hydrant is open here in the next picture, water flows through, but the drains are plugged. Okay, but once you go back to closing that hydrant here in the end, your water doesn't flow into your barrel anymore, but the barrel drains out these drains and usually into some, gravel that's situated around it and gives it somewhere to go, filters into the ground. If you were to open your hydrant halfway, you'd be in this opening piece where water's flowing into the barrel and water's flowing out your drains at the same time with some pressure, whatever pressure is at that hydrant. So ultimately, you can end up washing out that hydrant, causing a large cavity around it, or a puddle of quicksand or something, and could potentially cause a lot of damage. Very expensive damage to fix. So all the way open, all the way closed. Hazards. Improper hydrant use can cause contamination of the water supply. And generally these are tied to the same drinking water that everybody goes to, which contaminating that is a big deal. You can potentially damage underground water supply lines, usually through water hammer. operator can be injured. There can be a lot of reactive force with high flow operations. Um, if you're trying to hold on to the end of even an 1.5 inch hose flowing high volume, that can be very difficult. Also, a little water hammer and you're hanging around the top of a hydrant and something's going to fail, the top of that hydrant might be it. Albeit, I don't think that's as common as it once was. I don't hang out around the top of them, probably just because I was told not to once upon a time. Damage to the engine, attachments, fill controls, backflow prevention devices, or hose. Yeah, you can mess all that stuff up usually through some sort of water hammer. Generally, a hydrant isn't going to flow. It's going to be limited at something. And like my 2.5 inch hose plugged into my Type 3, I'm not going to be able to get more than 300 gallons a minute through it. So I probably am not going to damage the pump or anything by flowing too much water through that system. However, a slam of water coming up could cause some problems. It could be water hammer in one direction or the other. But be cautious of that. Learn backflow prevention is an entertaining conversation. We represent a bunch of agencies, and those agencies have some variable expectations. Everything from, well, you need to know how to use your hydrant and prevent backflow, to you have to do it exactly this way, and we'll kind of crawl our way through that and discuss it. But backflow prevention is important. You can cause a lot of very expensive damage to a water system by contaminating it with a backflow type issue. Do areas require the use of backflow prevention devices? Well, do they? I mean, really, where's that policy written exactly? And some places do and some places don't. And it's really to prevent that contamination factor. So my question is, how does it happen? How do we get backflow when you're pulling water off of a hydrant? So if you're hooked up to a hydrant, you're flowing water out of that hydrant into an engine, and you're doing it like I do, where you have a hose hooked up to your truck, and downstream or upstream or somewhere, somebody digs up a water line, and all of a sudden you have a big heavy draw on the system. Or you're out fighting fire in like a Type 1 engine with a big, 1,500 gallon per minute pump or bigger, hooks up to the 5 inch at 2 or 3 houses down and opens that thing up and starts blasting water. You can potentially have a reduction in pressure on that hydrant to the point where maybe water flows backwards. And if they can put a big enough load downstream, usually it's downstream, it could be upstream, but you can put a big enough load downstream, then water can get pulled backwards out of the hydrant I'm using, and theoretically out of the hose that I have hooked up to the hydrant, and theoretically out of the tank that I'm putting it into in my truck, except that there are ways I can make sure that doesn't happen. So backflow prevention devices, this is the expensive one. And I don't know if it was the BLM in general was requiring this or if it was just certain units, but there's some desire in all the federal agencies that you actually carry something like this around. It's a double or a triple check valve. I almost said bypass. It's a double or a triple check valve system that has that. That describes it there. And you can test it and make sure it works, and it doesn't allow water to flow backwards. That's the idea. And that's all great, and that's fine, and they cost a lot of money. And worse than that, they're very sensitive, and you can't bounce them around in, say, a fire engine that's driving around off-road and such. So consequently, they become a little bit unuseful to me. However, be aware that some locations may actually require you to have those. So you place it between the hydrant and the engine tank, preferably right next to the hydrant. You want to minimize the amount of backflowingness that you have. Local protocol regarding hydrant use is important, and not only local, but your own policy. So even if you're on the road, you should be following your own policy as well, especially if it's more restrictive and you're required to carry one of those things. Certify and test those devices annually, yes, and that is an expense. Use air gap method to refill if you do not have a backflow prevention device. That is one of the other solutions that you can use to prevent backflow. Okay, so backflow prevention the other way or some other ways. One possible option is use a check and bleeder valve. It can work as a backflow prevention device. I only have them an inch and a half, so if I'm using an inch and a half, that might be a solution that I could use. Um, the other way is soft suction. Never, ever use hard suction on a hydrant. Use hard suction on a dry hydrant, not on a hydrant, not on a dry barrel hydrant. Um, Always use soft suction. And if you use soft suction and you hook it up to your truck, instead of trying to top fill, you actually hook it into your number 8, like it's showing here in the diagram, and you follow your water system. So in through the number 8, in through the pump, and back into the tank through your number 2. That puts at least one check valve in place, and um, the next thing I do is I run my pump. Even if I run the pump at an idle and I'm pumping that water in there, I have some control. I can make some adjustments. I have compound gauges that tell me my incoming pressure, so I can neck that down with my number 2 valve if need be. And most importantly, I'm running my pump. So if I get vacuum or lose supply on my hydrant side, my soft suction hose will collapse and it won't allow anything to flow through it because my pump's running. And that is, that's how we teach backflow prevention for fire departments. So that's the other solution. But the key is you can't just, run it backwards through your tank to pump, which can cause a lot of damage to your tank. And you can't necessarily just run it into that dry fill, because if you run it into dry fill, I don't know, is there an air gap in that? Is there a check valve in that? Maybe there is. I don't have a dry fill. But if you follow the plumbing, the way the water's supposed to move in your truck can prevent backflow. So this is my preferred alternative. This is how I do it. That's how I do it on a municipal apparatus, how I do it on an agency apparatus. Same thing. And it works very well. Okay, critical. Never use hard suction. Almost every single one of the backflow issues we actually run into involves somebody using hard suction on a hydrant. The vast majority, that is where we end up with problems. It is important, but soft suction is a perfectly good answer. That's what most of the fire departments I know are doing. But remember that some locations will require you to use something more like the device. All right, so, and then you can air gap. There's some sort of an air gap method that you can use. Here it kind of notes it as this single permanently attached pipe that you can hook your hose up to. And yeah, that's great. It's functional. That gives you an air gap. And does it prevent backflow? Yeah. Does it work better than my pumping the water through soft suction? I don't believe so, but so be it. There's still some hose in that, or water in that pipe and in that hose, that I suppose you could suck back into the system. And at least with my way, it closes right where the vacuum starts. Anyway, let's see, requirements. Air gap distance is required to be at least 2 times the inside diameter of the pipe. Actually, I think it's 1.5, but 2 times is fine. And Use the manual air gap method. Okay, so our engines don't typically have this, even those dry fills. I'd like to see a dry fill that's actually rigged this way. I haven't seen one yet. You have that manual air gap where you hold the hose and spray it in the top of the tank. Um, it, this works. I've filled many an engine this way. Don't shove the hose in there and just leave it, because really the theory is that you could still get backflow issues. You got to maintain that air gap. So this can be a bit hazardous, especially in full line gear like that dude. But it is functional, and I think there's a lot of people out there that do it exactly this way. I think my main piece, or my main point here, will be when it comes to backflow, get to know what your requirements and policy are for your unit, not only for your agency, which vary a bit, but for your specific unit, because some forests are a bit more restrictive than others. And that's the general overview of hydrants. We'll be looking at a more hands-on how-to in person for part of the course. All right.